Okay, welcome to the video. In this session, we will talk about the mirror tree problem. So, generally, you are given the root of a tree and you need to convert the tree into its mirror image. It's nothing like it's just like you have to, for a given node, you have to change or swap its left node and right node. So we will analyze this in two methods, by using recursion and by using level order traversal. So first we will explore recursion. So basically in any general tree problem, if node equal to null, then we just return it. Okay, so else what shall we do here? Okay, so else we need to swap the left and the right child of a given node. Okay, let's do it now. So for swap we need to create a temporary variable struct node star temp equal to node star left node star left equal to node star right node star right equal to temp. Okay, so now we have swapped. This is nothing but we are doing swapping. So let's say now if we have only, let's say if we have only three nodes, one is root, one is the one is its left child and the other is its right child. So if we have only three nodes, then this is what we do. But let's say if the root has a left subtree and a right subtree, okay, not just one single node, but if it has a left subtree as well as a right subtree, then we apply recursion on left as well as right. So now we will apply recursion on the on the left as well as on the right. Okay, so now we'll apply on the right. So let's see if this works out or not. So let's directly submit the code. So now does it show any error? Okay, so generally we are swapping and doing recursion. So the thing is like, we for each node, think like you are at a single node. Think of only one node. What we should do if we are at one node? We need to interchange its left as well as right, and go to its left and go to its right. That's all. Here we are interchanging its left and right, that is swapping, and in this part we are doing recursion on the left and on the right. This is the basic part. Okay, so this okay. Now okay, we'll do with level order traversal. Okay, it's just to get an idea, so we'll do it with level order traversal. Okay, yeah, okay, so let's do it with level order traversal as well. So now, yeah, the basic thing, if node equal to null, then we just return else. Okay, so now since we are doing level order traversal, the first thing we should do is create a queue of type node star. See my previous videos for this. uh, Push the root and then the while loop. If queue is not empty, loop till the queue is not empty. Okay, okay, so now I mean like now so the same thing, we will create a temporary variable to access queue dot front, to access the front of the queue. So queue dot front. Now if the left child is present, then we will push the left child into the queue. If the right child is present, Then we'll push the right child into the queue. So queue dot push temp arrow right. Okay, now what shall we do? So one thing is, okay, q dot pop, we should not miss this, because if we miss the q dot pop, then it might, I mean, it will go to infinite loop. So q dot pop, these is the same thing which repeats in level order traversal. This part always repeats in level order traversal. You will create a queue, you will push a route, you will loop until the queue becomes empty. You will create a temporary variable to access the queue dot friend. You will see if the left child is present, you will see if the right child is present, you will push them. And now the modification comes. Now what shall we do? We need to, so this is our current node, right? So this is our current node. So this is our current node. So what we shall do is, like, we need to interchange its left as well as we need to interchange its left address and the right address. Okay, so we'll again create a temporary variable known as temp1, which is temp star left. And okay, we will now do the swapping. Okay, so this is generally the swapping part. Okay, this is generally the swapping part. Okay, now let's submit and see if this works out. So it should work out because this is very clear and it's not recursion type. Okay, root was not declared. Okay, what is given? Okay, node. Okay, okay, q dot push node. Okay, so this should work out because it's not a recursion. Recursion is hard to visualize and also it may take more errors. But yeah, this is working out fine. So that's all for this video. Thank you.